Dear students, in this video we are going to see about mathematical foundations. A section in this chapter is Eigen Values and Eigen Vectors. Now let's move on to finding the value of Eigen Values and Eigen Vectors of a given matrix. What do you mean by an Eigen Value? Eigen Value is nothing but determinant of A minus lambda I equal to 0. When we expand this determinant value A minus lambda I equal to 0, we get an equation in terms of lambda. Whenever you get an equation in terms of lambda, you have to solve for lambda. The lambda values are nothing but the eigen values of the given matrix. So, let A be an n cross n matrix. It is a square matrix of order n. An eigenvalue lambda of the matrix A is obtained from solving the polynomial determinant of A minus lambda I equal to 0. Lambda is called an eigenvalue of A if there exists a non-singular vector x such that Ax is equal to lambda x. So here lambda is the eigenvalue and x is the eigenvector for a given matrix A. Let's move on to the problem. Now we are given with a matrix A, a 3 cross 3 matrix. So it is a square matrix of order 3 and they have given that the product of two eigenvalues of this matrix is minus 12. So product of eigenvalues of this matrix is minus 12, but they have given it as product of two eigenvalues. Any 3 cross 3 matrix has 3 eigenvalues. Let them be lambda 1, lambda 2 and lambda 3. But under the given condition, we have two eigenvalues product is minus 12. So let us consider the two eigenvalues as lambda 1 and lambda 2. So we can write the given equation as lambda 1 into lambda 2 is equal to minus 12. But we know two properties. What are the two properties of eigenvalues? Product of eigenvalues is equal to determinant of A and sum of the eigenvalues is equal to trace of A. Trace means it is nothing but the sum of the diagonal elements of a given matrix. So let us use these properties and find the eigenvalues of the given matrix. Now, product of eigenvalues is equal to determinant of A means we have to expand determinant A. The given matrix, we have to find determinant A. When we find determinant of A, we get the value as minus 12. So, now product of eigenvalues is minus 12. So, product of eigenvalue means lambda 1 into lambda 2 into lambda 3. So, product of lambda 1, lambda 2, lambda 3 is equal to minus 12. So, whenever we solve this equation, we get the lambda 3 value as 1 because in our question they have given us product of two eigenvalues is minus 12. So, in place of lambda 1 and lambda 2, in place of lambda 1 into lambda 2, we substitute minus 12. So, when we solve for lambda 3, we get the value as 1. Now, let's use the next property. Sum of the diagonal elements is nothing but trace of A, which is equal to sum of eigenvalues of A. So, the eigenvalues of A is lambda 1, lambda 2 and lambda 3. So, whenever we add these three values, it is going to be trace of A. Trace is nothing but the diagonal entries 2 plus 1 plus minus 3. So, we get it as 0. So, trace of A is 0. So, we get the equation as lambda 1 plus lambda 2 plus lambda 3 is equal to 0. So, we put lambda 3 equal to 1, which we have got as earlier in this equation. So, we get lambda 1 plus lambda 2 plus 1 equal to 0. Hence, we can tell that lambda 2 is equal to minus 1 minus lambda 1. Let's use this equation in lambda 1 into lambda 2 equal to minus 12. So, when we use lambda 2 equal to minus 1 minus lambda 1, we get a quadratic equation lambda 1 square plus lambda 1 minus 12 equal to 0. A quadratic equation has two roots. So, lambda has two roots, two values. On solving it, we get lambda 1 plus 4 into lambda 1 minus 3 equal to 0 and hence lambda 1 is equal to either minus 4 or else 3. So, we get the three eigenvalues as 3, minus 4 and 1. So, a 3 cross 3 matrix has 3 eigenvalues. The next problem, we are going to find the eigenvalues and eigenvectors of a matrix A. Now, in this problem, we are going to find both eigenvalues and eigenvectors. An eigenvector can be found out corresponding to each eigenvalue lambda. Since this is a 3 cross 3 matrix, we have 3 eigenvalues, and corresponding to those eigenvalues we can find eigenvectors also. The given matrix A is here, and let us find the characteristic equation corresponding to the given matrix. A characteristic equation can be found out by evaluating determinant of A minus lambda I equal to 0. When we evaluate it, we get the equation as lambda plus 2 into lambda minus 6 into lambda minus 3 equal to 0. So, we get 3 eigenvalues as minus 2, 3 and 6. Now, let us find the eigenvector corresponding to the first eigenvalue lambda equal to minus 2. So, we are going to assume let x is equal to x1, x2, x3, a column matrix, be an eigenvector corresponding to lambda equal to minus 2. We are going to use the formula Ax is equal to lambda x. In place of lambda, we substitute minus 2. So, it becomes Ax is equal to minus 2x, and once again becomes the matrix A. We are going to substitute matrix A, and we are going to substitute the matrix X. When you accumulate them, we get 3 equations. We get a 3 set of equations. Among these 3 equations, 2 equations are same. The first one and the third one, they are same. So, the above system of equations reduces to 2 equations. Whenever it reduces to 2 equations, we can solve them easily. Using determinant method, we are solving them. We get x1 is equal to minus 2k, x2 is equal to 0 and x3 is equal to 2k, and randomly whenever we put some arbitrary value for k as 1, we get the corresponding eigenvector as minus 2, 0 and 2. So, an eigenvector corresponding to lambda equal to minus 2 is minus 2, 0, 2. Using the same procedure, we can find the eigenvector for lambda equal to 3 and lambda equal to 6 also. Thank you.